Our first chapter is all vocabulary. That's all. Just a whole bunch of vocabulary. The first two words aren't really test questions so much as they are just let us get started with some words so we understand each other. Data. Data is the answer to a question. You have a question, you want an answer, so the first thing you do is you go around and collect data. Statistics is what you do with that data to then try to answer your question. It might involve making some charts and graphs or tables. It might involve computing some numbers. When you collect your data set is one of two kinds. It's either a population or a sample. A population data set has answers from everybody that you want to study. A sample just has answers from some of the people you want to study. Most of the time we'll be dealing with samples because unless we have a very small and accessible population, it's not possible, or at least it's not practical most of the time, for you to get information from everyone in the population. If you do get information from everyone in the population, that's called conducting a census. A census isn't just where you count everybody in the whole country. That's one example, but a census means that I actually got information from everybody in the population that I care to study. A sample doesn't have an extra word because a sample comes from a sample, so that saves you one. Now, if the information that I collected was a number computed from a population is called a parameter. A number computed from a sample is called a statistic. For example, if that number that I computed was an average, if I found the average of a population, the parameter means it's dead on accurate. I had a bunch of numbers, but not only did I have a bunch of numbers, I had all the numbers that matter. So if I add them up and divide and I come up with an answer, that answer is accurate. If you look at the second half of the screen where it says sample, I only have 3 members of the population circled. If all I got was information from those 3 instead of all 7, I wouldn't get the same answer just by averaging 3 numbers together as I would from averaging 7 numbers together. Hopefully the 3 I picked would put me in the right ballpark, but it wouldn't be exact. So that's what a statistic is. A statistic is a number that you hope is in the right ballpark, but you don't expect it to exactly match the number you would get if you computed information from the entire population. When I collect data, it's one of two kinds, qualitative or quantitative. When I say I'm collecting data, I'm talking about getting the answer to a question. If the answer to a question is a word answer, that's automatically qualitative. A word answer is automatically qualitative. But sometimes I get number answers. Number answers can be either, so I have to think about those a little bit. If the number answer I get is a measurement or a count, that number is quantitative. Quantitative data is the kind of numbers that it makes sense to do math with. Now, sometimes there's numbers that don't actually stand for a quantity. They might as well be they could be letters. They're just labels. Like zip codes. Zip codes are numbers, but if I compare your zip code to my zip code, there's no difference, meaning they could be made up of different numbers, but if mine is bigger than yours, I don't have more of something than you do. So when it comes to numbers, you have to decide, is this a number that actually represents a quantity? Is it a number that it makes sense to do math with? If it is, then it's quantitative. If it's numbers like zip codes, area codes, your student ID number, those kind of numbers, it wouldn't make sense for you to like subtract them or anything. Therefore, those are back to the qualitative. Now, the numbers that are just numbers, the quantitative data, that can be divided up into two kinds. Now, we really talk about this more when we get to Chapter 6, but we'll introduce the idea now. Discrete means that you can have one or you can have two, but you can't have 1.5. Or maybe you can have 1.5, but you can't have 1.1. Every number is not a possible answer when it's discrete. For example, if I ask you how many pets do you have? You can have 3 pets or you can have 4 pets, but you can't have 3.2 pets. I have to jump from one whole number to another. Continuous means even if I don't measure it constantly, every single value in between two numbers is possible. So the example I have there in the picture is the speed of your car. It might go from 0 to 60 in 4.2 seconds, but somewhere along the line it reaches every single speed between 0 and 60 miles an hour. In other words, the change is smooth. It's not jerky. You don't jump from one speed to another. Same thing with like height or weight. Unless you pick up a rock, you really didn't gain 10 pounds instantly. At some point along the scale, you were every weight in between. There are 4 levels of measurement: nominal, ordinal, interval, and ratio. Now, nominal and ordinal, they're on this page together because these two apply only to qualitative data. So for the most part, we're talking about words. When I look at a list of words that are the answers that I got for a question, if it doesn't matter what order I would put those words in, that's nominal data. Ordinal means it has an order. Ordinal, order. And it's not just an order that I choose. It's an order that shows some type of progression from better to worst, hardest to softest, smallest to largest. But there is definitely a difference between the answers. It's not just a matter of putting something, say, in alphabetical order. That's a choice. That's not ordinal data. Ordinal, grades that you make. A's are better than B's. So the order isn't just alphabetical for grades. It is a progression. Nominal, the picture I had there are like colors. It doesn't matter if I listed those colors as the orange first or the yellow first. Nobody's going to say that one of those is mixed up. Interval and ratio, those apply only to quantitative data, so the numbers that are actual measurements. The difference between them is something called a natural zero. A natural zero means none. So if you have a natural zero, your data is ratio. I had for the picture there money. If I ask you how much money you have in your pocket and you say 0, that means you don't have any money on you. If I ask you how many children do you have, and you say 0, that means you have no children that you know of. Interval, 0 is just a point on a scale. 0 doesn't mean none. There's a lot fewer of those instances than there are ratio. Most things are ratio. But the example that I have pictured there is temperature. If I ask you what temperature it is outside and your answer is 0, that doesn't mean there's no temperature. 0 is just a point on a scale that in this case means it's cold. Year names is another example. If I asked you what year you were born, you'd give me a year. Nobody who's walking around today would give me the year 0 as what year they were born, but that's what you have to think about to decide whether it's interval or ratio. If you go back to year 0 is just a point on a scale. There were people walking around in year 0. Year 0 wasn't the beginning of time. So, temperature, year names, the time that it is on a clock, if you say 1 o'clock, 2 o'clock, 3 o'clock, those are your most common interval measurements. Once you collect your data, there's 2 ways to collect your data. Excuse me, I got ahead of myself. 2 ways of collecting data is an observational study or an experiment. The key difference between these two, observational, you're not actually doing anything. You're just letting people behave the way that they do and measuring whatever you're interested in. But you're not inflicting any change on them. In an experiment, you have 2 groups, and you actually treat the 2 groups differently. One group is your control group, so they either get nothing different or they get treated as things have always been. The other group is the one that it gets something different happening to them that wasn't happening to the original group. And there are 5 different sample collection methods. A simple random sample simply means that every member of the population has an equal chance of being chosen. Now, in a grown-up world, we wouldn't actually do this, but the simplest example is like drawing names out of a fishbowl. If you can't do that, even on a large scale, then you can't do a simple random sample. Think of the people in the class. I could put everybody's name on a piece of paper, put it in a fishbowl, draw them out. The key to that is not the fishbowl. The key to that is I would need a list of everybody who was in my population so their name could get in the fishbowl. If I don't have a list, I pretty much can't do a simple random sample. Systematic sample is when things are like in a line or a queue or objects on a conveyor belt. I pick a number and I pick a random starting place and I go with it. So I'm standing at FunFest, I can decide to pick every 3rd cooler that comes through is what I'm going to search. I could be standing at a factory and I can pick every 50th TV that comes down the conveyor belt, plug it in, make sure it works. Pick a number, go with it. A convenience sample, there's 3 different types. Convenience samples are very biased. If someone has used a convenience sample, you probably can't believe a bit of the data that they're telling you. So, first of all, a convenience sample is the people you would ask if I asked you to collect data. The people you know, the people you work with, the people who are in your classes, the people who you know on Facebook. You contact the people you already have contact with in some way. That's convenience. Like it or not, if they all know you, they already share similar interests, similar viewpoints, that's what makes the sample biased. Second way a convenience sample can happen is when the people who answer the survey, they kind of have to volunteer to do it. So they've come across the survey on a TV show or on a website, and it's just sitting there asking them to text or call in their opinion or their vote. When you have to find the survey and then you have to decide whether you're going to participate in the survey. Again, that's going to give you very biased results, which means you can't trust what it's saying because it's not the same results as you would get if you just asked man in the street or random people. Now, the third kind of convenience is not really so much convenient, but it's biased, so we put it in this group, is when what you're studying is so rare that you can't pick and choose where you get your data from. I have an example in my other class where we talk about measuring the brain size of Neanderthals. Well, there's only so many Neanderthal skulls available, so even though it's not exactly convenient to dig them up, we only have a few, so we can't pick and choose and eliminate any of them from our data set. So again, because they're rare, they probably have something in common than if we had a lot more of them, so your sample's probably biased. Convenient samples are not good sources of information. The last two are stratified and cluster. In a stratified sample, you divide your population into groups. Now, I have here some physical groups. You could have it divided into just groups that you have labeled in your head, like male and female, or I could divide the students into freshmen and sophomores. Whatever your choice of groups are, stratified means you take some from each group. So in this picture, I've got 4 different tables set up, and I've picked a chair from each table, and that will make up my sample. Cluster samples is kind of the same idea, except they are physical groups. I have a physical group. In this case, I have 5 physical groups. And then I choose, in this case, 2 of the tables. And everyone in the 2 chosen tables will then be my sample. So in a cluster, I divide into groups, then I pick a random couple of groups, and everyone in those groups is part of my sample.